In this video, let's go over the process of cross-validation, which is how we actually select a best value for our hyperparameter alpha with training data only. So the idea of cross-validation is simply that when we have a training data set, this is X data, Y data. We can break up this data set and only use part of it for the actual training of our model, and use the other part as a validation of the model that we just trained using the training portion. So this will be the validation set. And the idea is that because we didn't use this portion to train our model, this portion acts as a test data set that we can use to fine-tune what our hyperparameter alpha should be. And in practice, the thing that defines the cross-validation process is that we have a parameter n that determines how many times we segment our training data, the entire training data set. So in this example, let's set n is equal to 5. The actual number of n varies depending on how much data we have. We want to make sure that if we separated this entire training data set into 5 different segments, each segment it's still large enough that it's a representative sample of X data and Y data. So in this example, let's set n equal to 5. Then what we do is that we choose a value of alpha. So usually we do alpha as a range. So starting with alpha 1 to alpha n, where alpha 1 is less than alpha 2, that's less than alpha n. So we test a bunch of alphas, and we start with alpha 1. And what we do is that we take our entire training data set. Here, because n is equal to 5, we segment it into 5 random samples. And then we iterate through different partitions of these 5 segments. So for iteration 1, we will use, let's say, the first 4 segments as our training data. And then the last segment as the validation set, which is essentially the test data set. And because we have a fixed value of alpha here, let's just make this clear. Because we have a fixed value of alpha here, we can calculate how our model trained in this setting actually performs on this testing set. So we have some value of accuracy. Let's call that accuracy S1 of alpha 1. Now let's go into iteration 2. Here, we would now switch up this segmentation, and we would say maybe use this first part as our testing data set, and the rest of our data as our training set. And from this, we can again calculate an accuracy because alpha is still fixed as alpha 1. And let's call this S2 of alpha 1. And we'll repeat this for 5 times because here n is set to 5. So maybe on the 5th try, our testing data will be this portion. And our training data will be the rest. And our accuracy will be S5 of alpha 1. So now we see that for this value of alpha, alpha 1, we have, in this case, 5 different accuracy values. Let's just average that to give an accuracy value to this particular value of alpha. So let's call it S of alpha 1 is just 1 over n sum ideals 1n of Sn of alpha 1. So now we have an idea of how well our model performs on unseen testing data if we set alpha to equal to alpha 1. And of course, we will repeat this process for each alpha in alpha 1 to alpha n. And this will give us then a function, let's say big S of alpha, that consists of the accuracy score for each of these alphas. And our goal then is to now find the argmax of S of alpha. So we want to find the alpha, which is alpha star, that maximizes this function. And this alpha star is then the alpha we choose to actually train our model using our training data set so that we can expect to have the best performance on unseen testing set. So this is the process of cross-validation.